So hello friends, in this video we are going to discuss our Leetcode problem of the day. So now let's see the problem statement. Our problem is lucky numbers in a matrix. Basically it's a matrix problem. So I have taken a matrix in the right side. Okay. We have been given an m into n matrix of distinct numbers. Okay. This is basically here we have been given m and this is n. Okay. And written all lucky numbers in the matrix in any of the order. A lucky number is an element of the matrix such that it is minimum element in the row and maximum in its column. Means a lucky matrix is what? It is a minimum number in the row, but the maximum number in a column. So now let's discuss it with the help of an example. Suppose we have been given 3, 7, 8, 9, 11, 13, 15, 16, 17. So this is basically we have been given matrix. So first of all, let's see that minimum element in the matrix means minimum element in the row. Okay, so basically this is row and this is row. We have given three rows. Okay, so minimum element in the row is what? The first row it is 3, the second row it is 9, and the third row it is 15. Okay, now we have to see the maximum element in its column. Maximum elements in the column. Okay, so here maximum element is what? 15, here it is 16, and here it is 17. So as you are able to see, we have to return the common element. Common element means the lucky number which is minimum in the row. Okay, it is minimum in this row as you are able to see, but it is maximum in this column. Okay, wait a minute. Basically the 15 as you are able to see, the 15 is minimum in the third row and its maximum in the first column. Okay, so our answer will be what? 15 here. Okay, let's understand it with another example also. For example, we have been given 1, 10, 4, 2. Okay, 9, 3, 8, 7, 15, 16, 17, and 12. Okay, basically this matrix we have been given. Okay, we have been given three rows and four columns. Okay, we have been basically given three rows and four columns. Okay, in the vertical directions are columns. Sorry, horizontal directions are columns. Okay, and vertical directions are basically the rows. So basically, let's understand it. The minimum element. First of all, let's see the minimum element in the row. Okay, the minimum element in the row is what? It is 1. Okay, 1 is the minimum element basically. So now let's go to another row. In another row, the minimum element here is what? 3. 3 is the minimum element. Okay, and then third row, we have got our minimum element as 12. So 12 is basically the minimum element. Okay, so we have got the minimum of the rows. Okay, now see the maximum element from the column. Okay, let's see the maximum element from the column. We are able to see that the maximum element from the column 1 is 15. It's 15. Okay, now let's go move on to the second column. In second column, our maximum element is what? It is 16. Now in third column, our maximum element is what? 17. And in fourth column, our maximum element is 12 only. So now let's see the common element, which is both maximum and both minimum. Okay, maximum in the column, but minimum in the row. So in this given in values, we are able to see that only 12 is the number common. Okay, 12 is common. So our answer basically will be what? Our answer basically will be 12. Okay, in such case. Now let's move forward to another example. Let's suppose we have been given 7, 8, 1 and 2. Okay, we have been given 7, 8, 1 and 2. So now let's see we have been given two rows and basically two columns. Okay, so basically our minimum element from the row is what? It is 7, and our minimum element from row 2 is 1. Now let's see the maximum element. Our maximum element from the column is what? 7, and another column is what? 8. So now let's see the common element we have got here. The common element we are able to see is what? 7 and 7. Okay, in such case, our answer will be what? 7. Okay, so now let's try to understand it with another edge case. Okay, in another edge case. Okay, so let's suppose I take it as a 3, 6. Let's suppose it is the upper column is 3, 6, then 7, 1, then 5, 2, and then 4, 8. Okay, so we have been basically given 4 rows and 2 columns. Okay, as we are able to see that we have been given 4 rows and 2 columns. So now let's see the minimum element from each row. Our minimum element will be what? It will be 3, then 1, okay, then 2, okay, and then 4. Okay, so we have got our minimum element from each rows. Now let's see for the maximum element from each column. Our maximum element is what? 7. And in this 6, 1, 2, 8, our maximum element is 8. So basically, in this example, you are not able to see any element common, neither 7 or 8 in this, nor 3, 1, 2, 4 in this. Okay, so we are not getting any common element here. So in such case, what we will do? We will return just the null pointer. Okay, just the answer will be in null. Means we have no lucky number. Okay. In this case, we have no lucky number got. So we just return the empty list. Okay. So now let's try to understand it with the help of code. Okay. And subsequently, we will solve it by using the uh, approach also. So now let's begin. Okay. So basically, let's understand the code. Okay. First of all, in this question, let's see the first of all problem statement. Basically, the problem statement is what? In the form of list. Okay, as you are able to see, I will be solving the question in both Python and C++. So see the full video and understand the both the approaches. We are using the list here. Okay, with the square brackets. So first of all, we will import the list from typing import list. Okay, I have imported the list. Then we are going to see the minimum from each row. We are going to see the minimum from each row. Okay, so now let's see minimum element from each row. It will be basically the minimum sum of row for each row in matrix. Okay, or minimum. For example, let's make it more easier for you to understand. For row in matrix, our minimum in row, our minimum in row will be, it will be just minimum of row. It will be minimum of row. Okay. So we have got our minimum element in each row. Okay. Then we will find the transpose of the matrix, means the column. Okay. We are going to find the column of each matrix. Basically in Python, we use zip matrix. Okay. We are using the zip matrix. So now let's try to understand. So basically, for example, this is our matrix. Okay. This is basically our matrix. As you are able to see, this basically given is our matrix, and we have to find the rows. Okay, rows are already given. Okay, in the input, as you are able to see that the rows are already given 1, 10, 4, 2, 3, 7, 8, 9, 11, 13, and 15, 16, 17. Rows are already given, so iteration is very easy. But columns, this columns, each column is not given. So let's find the column here. Okay, let's find each and every column. So find that. So in that case, we will find the transpose of a matrix. Okay, transpose of a matrix is transposed matrix is equals to what? It will be list zip asterisk means the value of each matrix. Zip asterisk matrix. So now let's try to one time return the transpose matrix. Yes, now let's try to one time return the transpose matrix. How it will look. It's giving 3, 9, 15. Okay. Basically, it's giving us the 3, 9, 15. This is our row. Then 7, 11, 16. This another row. And 8, 13, 17. The another row. From this, you are able to see the another each columns. Okay. So now let's move on to another one. Okay. For example, I have created a list of lucky numbers. Lucky number equals to an empty list. Okay. I have created a for now for each column in transposed matrix. For each column in transposed matrix, I'm going to iterate through each column. Okay. So our maximum number in column, maximum number in column will be what? It will be max of each column. Okay. Then if if our max in column, if our maximum element in the column is in the minimum in row, means the common element in minimum in row. If it is so, means minimum in row means basically I mean to say this 15. Wait a minute. I am trying to say that the common element means this is the maximum in column and this is the minimum in row. We are going to find if there is a common element there. Okay. If it is so, we will just append it in the list. Okay, means lucky num dot append. Append what? Append the max in column. If the max in call is in the uh, row, so we will append it in the lucky number list. Now let's return the lucky number. Let's try to run the code one time. There is an runtime error it's giving if max in call in min in row. Okay, so argument of time int is not iterable. Okay, for example, in this row, let's try to make it more optimized. Okay, let's try to make it more optimized. Min in row equals to what? It is equals to minimum of row. Okay, for row in matrix. Okay, minimum of row for row in matrix. So we have been given here, and now let's try to run the code. Yeah, it's giving the correct output. Okay, now let's try to make the test cases here. Okay, let's try to make the test cases, means append more and more test cases here. Okay, this one, this another test case, and another edge case we have discussed here. Okay, this one 367152 3 comma 6 comma 71 comma 52. Okay, and the last is 48 basically. Yes, so now let's try to run the code. Yeah, so for each test case we are getting the expected output, means for this we are getting 15, then 12, then 7, and then for last one we are getting the empty list. Okay, so now let's try to submit the code. Yeah, it's getting accepted. So this was basically the okay. So now let's try to understand it with the help of C++ code, which will be more easier for us to understand. Okay, so basically, let's begin with the C++ code. So first of all, what we are going to do? Let's see the Python code. We have imported the list. Okay, in Python we have imported list. So similarly, in C++, there is an another one which is vector. Okay, another keywords are there. It is vector and algorithm and unordered set. Okay, algorithm is used for minimum element and maximum element, and unordered set is for maximum. Unordered set means maps and all. Okay, hash sets. So now let's begin. First of all, we will initialize the vector. Okay, include vector. Then basically include algorithm. Then at last, as the include, we are including the unordered set. Okay, these things we have been included in our code. Okay, so now let's begin with the coding approach. Okay, first of all, we'll find the minimum of value in each row. Okay, this is basically the minimum value in each row. Okay, and here we will find the minimum value in each row. Okay, so basically, let's wait a minute. Yes. So now let's begin with the code, main code. So we are creating a vector. Okay, vector int min in row. Okay, vector int min in row. Okay, then we are running a for loop for row in matrix. Okay, for constant auto ampersand row and matrix. Okay, now let's initialize the minimum value. Int minimum value. Int minimum value equals to what? It is equals to asterisk of min element, minimum element from the beginning of the row, from the beginning of the row till the end of the row. Okay, from the beginning of the row till the end of the row. So we have done with this. Now we will obtain the minimum element in the list. Okay, min in row dot pushback. Dot pushback minimum val. Okay, we have got it. Now let's we have find the minimum value in each row. Okay. So now let's move on to another step, means transpose of the matrix. Finding column of each matrix. Means finding column in each matrix. Okay. So now let's begin. We are going to initialize a vector. Okay, vector in transpose matrix. Okay. So vector in another vector in transposed matrix. Okay, vector in transposed matrix. Subsequently, go on seeing the Python code also. We are initialize the transpose matrix using the list and the zip variable. Okay, so now let's do it. Transpose matrix means matrix of 0. Okay, dot size. First of all, we'll see the size of the each matrix and then initialize another vector. Vector int matrix of size. matrix dot size. Okay, we have been done with it, initializing the transpose of a matrix. Okay, so now let's begin iterating through each matrix. So for size underscore t, I equals to 0, let's initialize I equals to 0. Then I will run the for loop from 0 till I less than and the size of the matrix. Okay, till I less than the size of the matrix. Okay, matrix I less than the matrix dot size, and we'll increment the incrementing the I. Okay, let's begin with another for loop for size of t. Size of t equals to 0. Okay, then size of t j equals to 0. I'm sorry, till j less than matrix x zeroth element of the matrix means the first column. Okay, matrix zeroth column dot size. Okay, and then we are going on incrementing the j, just going on incrementing the j, and then our transpose matrix will be there. Transpose matrix j of I equals to matrix of I comma j. Okay, so this we have got. So now we have got our transpose matrix here. Okay, as you are able to see, we have got our transpose matrix. So now let's move forward. Okay, so we are going to find the maximum value in each column and check if it is in minimum row. Okay, find maximum value each column, maximum value in each column, and check if it is in minimum row. Okay, so we have done with it. Now initialize our vector of int lucky number. Okay, we have as we have initialized the minimum row, we are initialize another list lucky number. Lucky number, yeah, lucky number. So now let's move forward. So for each element and in the for each means column in the uh, matrix, or we can say transposed matrix, whatever. Yes, for each column in the transpose matrix, we are iterating. Okay, we will initialize the max value. Int max value equals to what? It is equals to asterisk of max element. Max element from column dot begin. For example, we can say this line also for just same for the minimum and just same for the maximum. Okay. So now let's initialize it. Yes. So for it, we are using column dot begin as we have initialized the column. Okay, column dot begin in column dot end. Okay, so now let's move forward. We'll now check if the minimum in row is in the means the maximum value in each column. It is in the minimum of each row. Okay, so if find a minimum in row, to find minimum in row equals to what? Till begin. From minimum in row till begin, and from minimum in row till end and maximum value. Ah, and till maximum value until the maximum value of each element. We are going to check if it is not equals. Okay, if it is not equals to minimum in row that end. Okay, not equals to minimum in row dot end. Okay, we are going to check for it. Now we will append the lucky number in the list. Lucky num dot pushback. Lucky num dot pushback at max value, and just return the lucky number. Just return the lucky number. So basically the code is same for means the approach is same for both Python and C++. Just the difference is in the syntax and the length of the code. So the code which we have completed in 16 lines, it requires 35 lines in C++. Okay. So that's the difference between Python and C++. So this was basically the initializing the minimum element, means finding the minimum. But we have done it in one row only in Python. Then for transpose matrix, okay, transpose matrix we have required 4 to 5 lines. Okay, as you are able to see in both left and right. And then for finding the common element, okay. So this was the step 3 in C++ and Python. Now let's try to run the code. Let me copy the test cases here. Yes, now let's try to run it one time. Yeah, it's giving an error for line number 3, fatal error unordered. Now let's try to run the code. Line number 31, expected and end of the declaration. Chart 30. vector int mean in row. Okay. Now let's again run the code. Again a compilation error in line number 10. Int minimum val. Okay. No viable conversion from std vector to int in minimum val. Okay. For each minimum, let's make it minimum value. Okay. Again an error in that line only. Int minimum value. What's the main element? Sorry, we have forgot to use asterisk here, means the value of each element. Now another error. Yes, we have to make it a value here. And again, max value. Okay. There is an again expected semicolon. Now let's again run it. Yeah, so after many runs, we have got our expected output. Now let's try to run this. Yeah, we have been getting the expected and output as our result. So now let's try to run it. So basically, we have got our C++ code. Okay. So this was the C++ code, and basically this was just our Python code. Okay. So thank you, friends.